Hold on 1 second. Okay, remember what the parent function looks like on the absolute value?
For number 21, right?
Well, we did 21 last week, so let's look at 22. What is the parent function, which is y equals absolute value of x? What does that look like? Remember, that's the one that looks like a V?
Oh, yeah.
Okay.
So it would get wider?
Actually, it gets skinnier. The 3 makes it skinnier, makes it narrower. So like this. And what's the minus sign do?
It flips it?
So the final thing is this. Okay, that's a vertical stretch factor, and it's a vertical stretch factor because it's in front of the function being absolute value of x. And let's look at the next one, 23. Here we have y equals minus 1/3 absolute value of x minus 4. So you've got multiple things going on here. We'll start with this, although this is not the order we want to apply them. It's just the order in getting to know them. What's the negative 4 do?
For number 23?
Yeah, what's the negative 4?
Go to the right 4 times?
No? Remember when the number is on the end?
Oh, yeah, it goes down 4.
Okay. And what is the consequences of the 1/3 in front of the absolute value of x? If the consequences of this 3 was a vertical stretch by a factor of 3, what do you suppose the consequences of this 1/3 is?
Well, it's negative, so it'd flip, but it would get wider.
Yes. So you're right. It flips from the negative. That's the third thing going on, is it's a reflection.
Well, shouldn't we flip it first?
Yes. So the very first thing we want to do is flip it, and then move it 4 down, and then widen it. Which is that order that I did that in. Okay? Well, and we didn't talk about the domain and range. Once you've graphed it, it's pretty easy to talk about the domain and range. What is the domain and range of this one here? Now let me put the parent one in dotted lines like I should have. So the one we just graphed, the one in solid line, what's the domain of that?
All real numbers.
What's the range of it?
Y is less than or equal to negative 4.
Good. Okay. On 22, what was the domain of that?
All real numbers.
And what's the range of that?
Y is less than or equal to 0.
Good. Okay. Let's look at 24. Is that a function or not? Do you recognize that? What that is? Whoa. I don't think they meant this first y here. Maybe they did, but I don't think so. I think what they meant was this. This is the equation of something unique. And you can answer whether it's a function or not by knowing what this is. This is the equation of a circle whose center is at 9, 6 and whose radius is 10. So the circle is like that. Have you had conics yet? Have you had equations of circles? Marina?
Oh, I know that a circle isn't a function because it doesn't pass the vertical line test.
Okay, so that's not a function. I'm not quite sure why they put this y equals in front. I think that was inadvertent. I don't think they intended to do that. Because the equation of a circle is just this part of it. If you solve this equation for y, you end up getting two different functions. One of those functions is the positive part, and the other function is the negative part. So the equation for a circle is actually two functions put together. Each one of those would pass the vertical line test if it was up there by itself. In other words, if I had just the upper half of the circle, that does pass the vertical line test. Or if I had the lower half of the circle, that passes the vertical line test. But together they make the circle, which is not a function. It's called a relation. What type of function if they are a function? Okay, let's graph 25. It's in the graphing of these things that you can tell whether they're functions or not. So first of all, how am I going to graph this thing that may or may not be a function? I'm going to do it in two parts. What's the first part going to be? What's the first part of this piecewise function, if it is a function?
I don't really understand piecewise.
Okay, well, put two functions together. One function is going to be this.
Where are we doing 24 or 25?
25.
Okay.
Okay, so we're going to use this function whenever x is less than -2. Well, if this was the function the whole way, how would I graph that? In other words, let me take away that condition for a moment. Help me graph this. How do I graph that?
You'd have to wait for the first or the second one.
the first one. Y equals 2x minus 3. Help me graph that. It's in y equals mx plus b format. So how do you graph it when it's in y equal mx plus b format? Where do you start?
The slope?
Well, it's better to start at the y-intercept, which is what? What's the y-intercept? Okay, that's b, which is negative 3. So I would start there. And then what? What's the slope?
It's up 2 over 1.
Okay. So if I go up 2 over 1, I get a slope that's like that. And I'll draw it, the whole thing. Okay. So that's that first part plotted. Now the thing is that it says that it's only that when x, I didn't do it, let me plot it again down here. Use a little different scale. That's minus 3. And over here, I'm going to put minus 2. So what it's saying is that the function is going to look like 2x minus 3, but only when x is less than minus 2. Well, where is that? That occurs right about there. So the only part of this function really is this part right here. And I can erase the rest of it. So far that's what we've got. Now, when x is greater than negative 2, in other words, whenever x is to the right of negative 2, we have a different function. We have this, minus 2x plus 4. Well, let's graph that as if it were the only thing. Where would we start? How would you graph y equals minus 2x plus 4?
Wait, I'm confused about the first one still. Like, since it's that equation if x is greater than negative 2, so wouldn't it be the top half, not the bottom half?
No, we're looking at x. X refers to the horizontal axis. Y is the vertical axis. So we're saying whenever we're to the left of negative 2 on the horizontal axis, the function is going to be y equals 2x minus 3, which is this straight line that I've got down here. And now we're saying, well, whenever x is to the right of negative 2, the function's going to look different. It's going to be minus 2x plus 4. So let's plot that, and I'll show you how it works. How do we plot y equals minus 2x plus 4? Where do we start?
The y-intercept, which is 4.
Okay, so that's this point right here. And then what?
And then since it's negative, it's down 2 over 1.
Okay, so down 2 over 1. I know what negative looks like. It looks like this. So that's what that line would look like, but it can only begin right here. So it doesn't look like that. I have to erase the part of it that's less. I have to erase the part where x is less than 2. Excuse me, less than negative 2. You see that? Where I have to erase that part right there so that the only part I'm left with has x's that are greater than -2. So now we have this strange-looking piecewise function. Is that a function?
Yes.
It does. It passes the vertical line test. Now, the key thing is what happens at -2. Well, if this was really a closed dot and if this was a closed dot, it would not pass the vertical line test. Because as we passed our vertical line over the x equal -2 point, we'd have two different values for y. But it says the first function is only true when x is less than -2, which means we have an open circle here. And when x is equal to -2, we have a closed dot there. So that passes the vertical line test. And the way you graph these piecewise functions is graph it without the restriction. Let me do that. If I were to graph this without the restriction on either function, it would look like this. Right? If I were to just graph both functions. Marina?
Yeah.
Okay. I don't know how much you heard. It sounded like your audio was out for a minute. If I were to graph both of these functions without the restriction on them, it would look like this. The dotted line is the portion that is restricted. In other words, this function is only this true when x is greater than or equal to -2. And this is the function only when x is less than -2. So I can't put these dotted lines on it. They don't belong there because that's not what the function is when x is greater than -2. Okay?
Okay.
All right, let's see if you can graph 26. I'm going to leave my... What's the first part of the function?
The y-intercept, which is 1.
Okay, so the first thing we're going to do is graph this one. So we'll call this 1 and...
And it goes up by 1.
Okay, so its slope is 1. So I'm going to make a positive slope, that goes through that intercept. And this part of the line I'm going to make dotted, only as a way of explanation. In other words, this is the function whenever x is greater than 0. So there needs to be a circle right there. It's only to the right that I'm going to graph this part of the line. Do you get that? Do you get that? Do you understand why that's the case?
Yeah.
Okay. In other words, once we put that restriction on there that x has to be greater than 0 for it to be equal to x plus 1. If x is less than 2, it's equal to this other thing. Okay, so let's plot the other thing. The other thing is y equals -2/3 x minus 1. Let's graph that whole thing. Where would I begin?
The y-intercept, which is -1.
Okay, and what's the slope?
Negative 2 over 3.
Okay. That slope, if it's negative 2 over 3, let's see, here's 2 on the x. But if I were going to graph that whole line, I would do it this way. Okay. There's the slope, negative 2 over 3, and I'll graph the rest of the line. But notice that it only is that when x is less than 2. So I need to go back and erase that dotted line that I put in there. This is what it's supposed to look like. And it's less than or equal to 2, so I have a closed dot there. So this function applies to that part, and this function applies to this part. You see how it works?
Yeah.
Is this a function?
Yeah.
To pass the vertical line test?
Yeah. Because it doesn't pass more than one vertical line.
What if I draw a vertical line right there?
It won't pass it more than once.
It does pass it more than once. It passes the function there and it passes it there.
Oh, I thought you meant only like one line at a time.
No. For something to pass the vertical line test, you can't just cherry pick and find a spot over here. It has to pass the vertical line test if I move that vertical line throughout the domain of the x. In other words, it's like taking a playing card and moving it to the right where you always have a vertical line. This fails the vertical line test. It only has to fail at one point for it not to be a function. In other words, even if I made this like this, and I put closed dots at both of these, that fails the vertical line test. It only fails it in one spot, and that's where the y-axis is. But it does fail it in that spot. In other words, when x is equal to 0, what would y be? Both plus 1 and minus 1. So you would have two values of y for a given value of x. That's not a function. In our case, it was even worse because it went all the way to there. So we had this entire area between there and there where it was not a function. Okay. If they are, what type of functions do they represent? Well, this was a circle, which is not a function. This was a piecewise function. This was a piecewise relation, but it's not a function either. 27. Y equals 3x minus 4 cubed. What would the parent, if this is a function, then it must have a parent function. What would its parent function be? Most elementary functions are created from a transformation of the parent function. What would this parent function be?
Well, don't we have to cube it?
Well, you're on the right track. What is the parent function? Not this function. What's the parent function? The parent function is y equal x cubed. This is merely a modification of that. So we need to know how to plot y equals x cubed. That'll go a long way towards figuring out whether this is a function or not. Well, if you plot y equal x cubed, it looks like this. Is that a function?
Yes.
It does. It passes the vertical line test. In other words, no matter where we're at on the x-axis, there's only one value for y. It doesn't loop back on itself. So if we recognize that this is merely a translation of this, and what kind of translation is it? What's the minus 4 do?
It makes it go right 4 times?
Yeah, although not exactly true with this one. But because we actually, in order to figure that out, we have to factor this 3 out and get it outside the function. Yeah. In other words, I have to actually write this in the following method. If I write it like that, now you can say that this 4/3 is the right shift. So we would take this curve and shift it to the right. And you could say that the 3, what's the consequences of this 3 now? Remember, it's inside the function, not outside. It has a completely different result than if we had a 3 outside the parentheses. By outside, I mean outside what's being cubed. This is inside what's being cubed, which means that it has the effect of a horizontal shrink. It's not a horizontal stretch. If the 3 was outside, it would be a vertical stretch. But since the 3 is inside the function, then it's a horizontal shrink, which means is all we're going to do with this curve is squish it together a little bit. Instead of looking like y equal x cubed, if I wanted to draw y equals 3x cubed, it would look something like that. And then if I wanted to draw y equal 3x cubed or 3x minus 4/3 cubed, I would take this middle one here and translate it to the right by 4/3 unit, but you can tell that that's not going to change. In other words, a horizontal translation will not turn a function into a non-function or vice versa. If this is a function, then if I horizontally move it right or left, it's not going to change it. Still will pass the vertical line test. If I horizontally shrink it, it's not going to change that. In other words, it will still be a function even if I horizontally shrink it. If I vertically stretch it, it will still be a function. A vertical stretch has the same effect as a horizontal shrink. That's a vertical stretch, but it's still a function. And if I move it up or down, it doesn't change whether it's a function. In other words, y equal x cubed plus 1 would still be a function.
Okay.
And as to what kind of function, that's a cubic function because its parent is y equal x cubed. Okay?
Okay.
So do you have anything else to work on?
I might have some problems
Can you
verbally, if I can tell you.
Can you verbalize them?
Or actually, it's a story problem.
It's okay.
Okay. It says, a group of students go out of lunch. If 2 have hamburgers and 5 have hot dogs, the bill will be $8. If 5 have hamburgers and 2 have hot dogs, the bill will be $9.50. Write a system of equations to find the cost of each hamburger and each hot dog.
First one was 2 hamburgers, 5 hot dogs. The second one was what?
It was 2 hamburgers and 5 hot dogs, and the bill is $8 for that. And then the second one's 5 hamburgers and 2 hot dogs.
Okay. So the very first thing we want to do when we're looking at word problems is assign variables and say what they mean. Okay? So assuming that I want to use x and y as my variable here, what would you let x be? In other words, they said set up a system of equations that we're going to solve. Well, that system of equations is going to look something like this.
I did x equals hamburgers and y equals hot dog.
Okay, but is
And then I did
it the number of hamburgers or is it the cost of a hamburger?
the cost.
That's a critical difference. And this is why I generally recommend all my students do this when you're solving a word problem. If you do this first step, you will be able to solve almost all word problems, I swear. And y is the cost of a hot dog. So what is the first equation that I can write?
I did 2x plus 5y equals 8.
That's correct, because we're going to take the cost of a hamburger, multiply it by 2 for 2 hamburgers, and that'll be the total cost of the hamburgers. This will be the total cost of the hot dogs. Together they equaled 8. What's the second equation I can write?
5x plus 2y
Equals
9.5.
Now can you solve these two equations? I'm going to rewrite them just so, because this is a particularly difficult one to solve. So I want to make sure I give us room. How do you solve these two equations? First of all, what are the two methods for solving equations? Substitution, and what's the other one?
And elimination.
Okay. When it's in this format, elimination usually works easier, just because this is the perfect format to use elimination on. However, it's not easy to multiply one of these equations by something and get it to a point where I can eliminate a variable. Remember, that's my goal, is to eliminate either x or y. We don't care what. And remember the rules of equations. I can do anything I want to the left side as long as I do it to the right side, and I can also add or subtract equations. So what do I need to do to this top equation? And I may have to do something to the bottom equation also, so that I can get these variables to go away.
multiply both sides by 2.
Which one, on the top or the bottom?
Top.
Okay. So I'm going to multiply the left side of the equation by 2 and the right side by 2 because I can do it. Okay. What that results in is 4x plus 10y equals 16. So that is now, hold on, let me turn my camera off and hopefully this thing will go away. So now I've got this equation instead of this one. So I'm going to erase this one. I don't want to erase it completely. In fact, let me number it. This is equation number 1, this is equation number 2, and this is the same as number 1. So I still don't have these two equations in a format where anything gets eliminated if I add or subtract them. But what can I now do to equation 2?
Multiply by 2 also.
Well, that won't get anything to disappear. That'll turn this into 10x. But we need to turn this into 10y is what we need to do. What if I multiply equation number 2 by 5?
Oh, because then it would be 10y, but it's 10y, yeah.
5 times this is 47.5. And this is now equation number 2. So now I can work with equation 1 and 2 right there. The new equation 1 and 2. And I can choose to subtract one from the other. Just to make things a little bit easier, I'm going to put the smaller equation underneath. In other words, I'm going to write this 4x here. This is equation 1. And I'm going to subtract equation 1 from equation 2. What does that leave me? In other words, our goal is to eliminate a variable. Well, I can get rid of y. If I subtract equation 1 from equation 2, y will disappear. What happens to everything else? How many x's do I have?
21.
How much numbers do I have?
31.5.
So x is now equal to 31.5 divided by 21. And that solves for x. But now I have to go back in and substitute this into one of my equations and then solve for y. And that's fine. It's just the final step. In other words, once you've eliminated that variable, you solve the one equation and one variable that's left, which solves for x, but then you have to go back into any of the original equations. We could go all the way back into the shortest one if we want. Let's go up into this number 1 and substitute 31.5 over 21 for x and then solve for y. Now, there is a problem here. Oh no, there was no problem. I was thinking that because we have a fraction here, is all that means is our cost for a hamburger is like $1.50. Yeah, that's exactly $1.50 per hamburger. 31.5 divided by 21 is $1.50. So hamburgers cost $1.50 must mean hot dogs cost $1. Because if I substitute $1.50 here and solve for y, y is going to end up being $1. 2 times that's 3, 5 times that's 5, 3 plus 5 is 8. There's no 2 over here. Okay? So even though they didn't tell us how much hamburgers and hot dogs cost, by giving us 2 equations, we could solve for it. As long as they give us 2 separate equations. If they'd only given us the first equation, we could not have solved for it. If they had merely said that 2 hamburgers and 5 hot dogs cost $8, there's an infinite number of combinations that will do that. Okay. Do you have any others you can verbalize? Let's try another word problem, because word problems tend to give everybody difficulties, and I'm absolutely convinced that if you do this step, define your variables and spell out exactly what they are, you'll be able to solve word problems easier.
Do you want to make up a word problem? Because I don't think I have any more.
Hard for me to make them up. Let's see. Yeah. 2 numbers that, let me write it out. 2 numbers. In fact, let's, two consecutive even numbers that add to 10 and multiply to 24. So what's the first step, remember? What's the first step of a word problem?
Wait, does that say 2 coins, even number?
I'm sorry, 2 consecutive even numbers. And I don't want you to guess and figure out what these 2 numbers are. What I'd like you to do is to solve this algebraically. In other words, let's start out by defining the variable and what it means. So what's my variable going to be? In other words, the question, to figure out what your variable should be, always look to the final question they ask in a word problem. What are the numbers? So x is what? I could say x is the first number and y is the second number. You see what I'm getting at?
Kinda.
The key in any word problem is to assign a variable and say what it means. They're asking me what 2 numbers, even consecutive numbers, add to 10 and multiply to 24. Well, if I let x be my first number. I could let y be my second number, but I don't really need to introduce a second variable. What's my second number got to be? If it's two consecutive even numbers, the second number's got to be x plus 2. So there's my two numbers, x and x plus 2. That's what consecutive even numbers means. Okay, so now if I want to set up my equation, what's my equation going to be? The first equation says what? That my two numbers have to add to 10. So what equation says that? Marina?
Can you hear me?
I can hear you. This is my first number. This is my second number. What equation tells me that those two numbers add to 10? Add them together.
Wait, so x plus 2?
Equals 10. What's the second equation? What equation says that they multiply together to equal 24?
Maybe x times x plus 2?
Okay, there's equation number 1. There's equation number 2. In this case, I can actually solve it from one equation alone because I only have one variable. But if I solve this first equation, I got 2x's plus 2 equals 10. Therefore, 2x is equal to 8. Therefore, x is equal to 4. So x equals 4. 4 is my first number. What's my second number? Since it has to be a consecutive even, it has to be 6. 4 plus 6 equals 10. 4 times 6 equals 24. And in this case, I could have actually used y instead of x plus 2, and I could have just said two numbers without putting that in there because I had two equations. So I could have used y is my second number, and then I would have had x plus y equals 10, and then I would have had x times y equals 24, and I could have solved for both x and y. All right. You should probably try to get a hold of some more word problems that we can work on, because I can help you on word problems by merely getting you to do the same thing every time. People fail on word problems because they don't start it out correctly. It's really, really easy. Look at the last sentence of the word problem. Make that your variable. Whatever it is they're asking for, make that your variable. Then set up your equations based on the first two sentences of the paragraph.
Yeah, I have a lot of troubles with word problems.
Everybody does. It's because they don't follow that methodology. If you follow that methodology every time, you will not have trouble with word problems. It's just doing that process. Don't skip the first part of that process, which is to label your variables and say what do they mean. Don't just label them. You can't just say X is hamburgers. That didn't work. You had to say X is the cost of a hamburger, which is what they wanted to know. They didn't want to know how many hamburgers there were. They wanted to know what was the cost of a hamburger and what was the cost of a hot dog. So be very specific when you label your variables. If you're specific enough, then the equations that come flow automatically. So all you have to do is read the first sentence again to get 2x plus 5y equals 8. Then read the second sentence, which gives you 5x plus 2y equals $9.50. All right, let's call it a session if you don't have any other problems.
Nope.
Okay. Let's see. Your mom has you scheduled again for Wednesday at 2:30. Is that right?
Yeah.
Okay. I will talk to you then.
Okay.
All right, Marina. Bye-bye.
Thank you. Bye.